All right, number 14. F of x equal to 2 to the x plus 1. The function f is defined by the equation above, which shall find is a graph of y equal to negative f of x in the xy plane. Okay, so we have this is the function. And what we have here, this is an exponential function. Okay, we have 2 to the x power, so x in the exponent, right? And then plus 1. Okay, so what we could do is we could graph this, right? Graph the original function. Yeah, so we can graph the by plugging, you can either plug in some numbers, right? Plug it in. And then from that, we can find a new graph. Okay, so we're trying to figure out which one is the negative f of x. So pretty much, if you have a negative in front of the function, that will be a reflection. Okay, so the whole graph will flip over the x-axis because the negative in front will be a reflection over the x-axis. Okay, another approach is we can find the equation for the new function first, and then from that we can try to match with a graph. Okay, so let's go and do that. And if you put a negative in front of the whole function, you see now it used to be f of x is 2 to the x plus 1, right? So we're gonna make the whole function negative. So we'll put it in parentheses. So it'll be 2 to the x plus 1, and then we're gonna make this whole thing negative. Yeah, so put a negative in front of the whole thing. And here we do have to distribute the negative. So the equation is pretty much negative 2 to the x minus 1 if you distribute the negative 1. Okay, so we had to see which one is the correct graph for this one. We could just do some test point. Okay, so we do like a test number, and that should be a good approach here. So we make like a little table, x and y. So if you plug in like when x equal to 0, we can actually solve for the y value and see what we get. Right. So you see if you plug in x equal to 0, this will be negative 2 to the 0 minus 1. And what's 2 to the 0? Well, 2 to the 0 is a special rule with exponent. So anything raised to the 0 power is always equal to 1. Because now equal to 0 is actually equal to 1. So this will be negative 1 minus 1, which is just negative 2, right? So when x is 0, we get y equal to negative 2. So we should have a point 0 comma negative 2 on the graph. And that's a y-intercept, right? 0 comma negative 2. So out of A, B, C, and D, which one has that? Well, only answer choice C has that, right? Okay, all the other one doesn't go through 0 comma negative 2. So you can pretty much eliminate all the other ones. So C had to be correct. Okay. We could plug in another point just to make sure we plug in 1, right? We get y equal to negative 2 to the 1 minus 1 will be negative 2 minus 1 will be negative 3. Okay, so you should get 1 comma negative 3, which matches as well. Okay, but it's the answer choice C. All right, so what happens, the original function, if we graph it, this will be a exponential growth function, right? And then we have a vertical shift up 1. So it'll be like a horizontal asymptote at 1, and then it will be like this. Okay, but then if you reflect it, do a reflection, the new graph will open downward like that. Okay, and the horizontal asymptote now will be at negative 1. Okay, so yeah, so the new graph will be like that, and then so that will be C for our final answer. Okay, yeah, that's it for this one.